Well, hello and good morning. Today I'll be discussing another paper here. This one, I'll also link in the description, is on more directly on alignment work. It's scalable oversight for superhuman AI via recursive self-critiquing. This is a relatively recent paper. It was published like literally 2 days ago on May 30th to Archive, and it is really a paper coming out of China, and it explores an idea that is very popular or common in alignment work, which is how do you keep a model aligned when it's far more powerful than you are? And people have different kind of ideas around this, but generally the idea is that you seek to prove that you can use a less sophisticated model that you do know is good, is aligned, to supervise or critique or monitor or verify the outputs of a more powerful model. So you need to kind of show this like iterative process where, like, if you have, if you can verify model n, then you know that model n can verify the outputs of model n plus 1. And so in theory, even if models are way past human abilities, if they comprehend things way more than humans do, still they would be restricted. They would be kept in alignment by the previous version of those models. So in this paper, I kind of went through it, and from what I understand, they essentially gave a bunch of benchmarks for the model. Like a bunch of tasks, whether it's like mathematics tasks, they gave it a bunch of like standardized exam questions, stuff like this, and they had the model like perform its actions, and they show how accuracy is affected with if you add like levels of abstraction of critiquing of the responses. And the idea is that you can use more critiques, that the more critiquing that you're using, the easier the problem becomes. Like, it's easier to critique than it is to come up with the right answer. And so they use that to argue that this is a promising thing to look into. So I mean, I think it's, in theory, it's reasonable, but there are, of course, the issues of how do you ensure that the verifier is giving you accurate answers. So in real life, if this is going to be used for alignment, you really need to be sure that you understand the verifier very well. And also, you also need to be sure that there isn't, and to be fair, they do acknowledge this, that if there's a massive jump in performance between model n and model n plus 1, the verifier will have a harder time to verify that the output of the n plus 1 model is correct or not. So you sort of need the verifier to be in the same ballpark of abilities as the model that it's going to verify. That's the first thing. And then you need to be absolutely sure that it is actually, that its outputs are valid, are aligned. And both of those are very difficult things to establish. And it's hard to know how that changes when you actually begin to have models that are, like significantly above like a human level. So it's an interesting paper. It was a good read, but and it's an interesting direction to think about. But there are definitely a lot more issues that need to be addressed with this approach. So that's pretty much it for today. So I'll talk to you guys again later. Goodbye.